Number 10. They rip stars apart like tissue paper. Black holes rip stars apart like tissue paper. When a star gets too close, the black hole's gravity stretches it into a stream of superheated gas. This is called spaghettification. The name is both scientifically accurate and emotionally rude. Tidal force. That is the mechanism. The difference in gravitational pull across an object. Your feet experience more gravity than your head if you fall feet first. The difference stretches you, not gently, violently. Your body elongates into a thin strand of atoms. It happens to stars 1,000,000 times larger than Earth. It happens to planets. It happens to spacecraft. It happens to human bodies. The black hole does not distinguish. It does not care about structural integrity or molecular bonds. It applies differential gravity and everything stretches. The stretching happens before the event horizon. You do not make it to the point of no return intact. You are destroyed in the approach. Tidal forces near a stellar mass black hole are strong enough to shred you while you are still, technically, in a region of space you could escape from, if you were not already a stream of disassociated particles. Friction heats the stretched material to millions of degrees. The star becomes plasma. It glows in X-rays. What was once a coherent sphere of fusing hydrogen is now a glowing thread spiraling into oblivion. Astronomers observe this. Tidal disruption events. A star wanders too close to a supermassive black hole. The star is torn apart. The debris forms an accretion disk. The event outshines the entire galaxy for weeks. In 2019, astronomers observed at 2019 KIS a star being shredded by a black hole 215 million light-years away. The destruction was visible across intergalactic space. There is no dignity in spaghettification. The universe does not grant quick deaths. It stretches you into a filament, heats you into plasma, and feeds you into a region from which nothing returns. Number 9. Nothing escapes once it crosses the event horizon. Nothing escapes once it crosses the event horizon. Not light, not matter, not information in any usable sense. The event horizon is basically the universe saying, no refunds. It is not a physical barrier. It is a mathematical boundary. The Schwarzschild radius. The distance from the singularity where escape velocity equals the speed of light. Inside that radius, escape velocity exceeds light speed. Nothing moves faster than light. Nothing escapes. Light itself cannot escape. Photons emitted from inside the event horizon are pulled back toward the singularity. They do not make it out. This is why black holes are black. They emit nothing. They reflect nothing. Any light that crosses the boundary is trapped. The black hole becomes absolute darkness, surrounded by the glow of matter dying just outside. Time slows down near them. To an outside observer, something falling into a black hole appears to slow down and freeze near the edge. It redshifts. It dims. It appears to stop. From the outside perspective, the fall takes infinite time. The object never appears to cross because time dilation stretches the moment to infinity. From the falling object's perspective, though, it keeps going straight into doom. Time passes normally. The event horizon approaches and is crossed in finite time. No pause, no freeze frame, just continuous fall into oblivion. Both perspectives are correct. The universe does not reconcile them. You cross the horizon from your perspective. You never cross from the outside perspective. Both are true simultaneously. The universe enforces this split and offers no explanation. Once you cross, you are gone from the causal structure of spacetime. Erased, inaccessible, unreachable, lost. The event horizon is not a suggestion. It is a law enforced by geometry itself. Number 8. Supermassive black holes sit at the centers of galaxies, including ours. Some are millions or billions of times heavier than the Sun. Supermassive black holes sit at the centers of galaxies, including our own Milky Way. They are not anomalies. They are standard galactic architecture. Sagittarius A* is roughly 4 million solar masses. It sits 26,000 light-years from Earth. We orbit it. The entire solar system, along with hundreds of billions of stars, revolves around Sagittarius A*. We are in its gravitational well. We have always been in its gravitational well. It is currently quiet, which is the only polite thing about it. Sagittarius A* is not actively feeding. It is dormant. But dormant does not mean harmless. It means the threat is not currently active. The mass is still there. The event horizon is still there. The gravitational influence still shapes the orbits of stars near the galactic center. Stars orbit Sagittarius A** at speeds exceeding 5,000 kilometers per second. The star S2 completes an orbit every 16 years. Its closest approach brings it within 17 light-hours of the event horizon. Observations of S2's orbit provided some of the strongest evidence for Sagittarius A**'s existence. The star's motion can only be explained by millions of solar masses compressed into a region smaller than Mercury's orbit. Every galaxy with a bulge has a supermassive black hole at its center. This is not coincidence. This is pattern. Surveys show consistent correlation between black hole mass and galactic bulge mass. Bigger galaxies have bigger black holes. The relationship suggests supermassive black holes and galaxies grow together. M87* has a mass of 6.5 billion solar masses. It was the first black hole directly imaged by the Event Horizon Telescope in 2019. The image shows the shadow of the event horizon surrounded by a glowing accretion disk. The black hole itself is a dark circle. The light around it is matter dying at billions of degrees. Ton 618 has an estimated mass of 66 billion solar masses. Its event horizon has a diameter of roughly 1,300 astronomical units. That is 40 times the distance from the Sun to Neptune. The entire solar system could fit inside its event horizon with room to spare. When supermassive black holes feed, they outshine entire galaxies. When they are quiet, they sit in the dark, accumulating mass. We orbit one. Every galaxy orbits one. The universe did not just create black holes. It built galaxies around them. Number 7. They can fire jets across entire galaxies. Black holes do not just suck. When matter spirals around them, magnetic fields can launch enormous jets of particles moving near light speed. These jets can stretch for thousands or even millions of light years. The accretion disk generates the mechanism. Matter spirals inward. It becomes ionized plasma. Moving charged particles generate magnetic fields. The fields twist and amplify as the disk rotates. Near the black hole's poles, magnetic field lines become so tightly wound they act like particle accelerators. Material gets funneled along these lines and ejected perpendicular to the disk at 99% the speed of light. The jets are not small. They are galactic-scale weapons. The supermassive black hole at the center of M87 produces a jet stretching at least 5,000 light-years. That is longer than the distance from Earth to the center of the Milky Way. The jet from Centaurus A extends for roughly 1,000,000 light-years, 10 times the diameter of the Milky Way. These jets carry enormous energy. They trigger star formation in gas clouds. They suppress star formation by heating gas too much for collapse. They reshape galaxy structure. They inject energy into intergalactic space. A single jet from a supermassive black hole can influence the evolution of an entire galaxy cluster. Quasars are supermassive black holes with jets pointed at Earth. When we observe a quasar, we are looking down the barrel of a relativistic particle beam. The first quasar identified, 3C273, was discovered in 1963. It is 2.4 billion light-years away. It outshines its entire host galaxy. The jet from 3C273 extends for at least 200,000 light-years. The brightest objects in the universe are not stars, not supernova. Black holes actively feeding. The accretion disk glows in X-rays. The jets glow in radio waves and visible light. A single supermassive black hole in a feeding frenzy can outshine 1 trillion stars. Black holes do not just destroy locally. They broadcast destruction. They fire particle beams across cosmic distances at speeds that make interstellar travel look like a joke. The jets persist for millions of years, carving channels through intergalactic space, reshaping gas distribution in galaxy clusters, leaving scars that outlast most stars. The black hole itself is dark. The violence it projects is not. Number 6. A small black hole could be worse than a giant one. Intuition says bigger is scarier. Intuition is wrong. A smaller black hole can kill you more violently. Tidal forces. The difference in gravitational pull between your head and your feet. The strength scales with mass divided by radius cubed. A smaller black hole has a much steeper gradient near its event horizon. Stellar mass black holes range from 3 to 20 solar masses. Their event horizons are small. A 10 solar mass black hole has a Schwarzschild radius of roughly 30 kilometers. Tiny compared to a supermassive black hole with an event horizon millions of kilometers across. The smaller radius means sharper gravity drop over short distances. If you fell toward a supermassive black hole, tidal forces near the event horizon would be relatively gentle. You could cross the horizon intact. You would still die at the singularity, but you would make it past the point of no return in one piece. If you fell toward a stellar mass black hole, tidal forces would rip you apart before you reached the event horizon. Your feet would experience significantly more gravitational pull than your head. The difference would stretch you into a thin stream of superheated plasma while you were still, technically, in a region you could escape from, if you were not already shredded into subatomic particles. This is the irony the universe offers. The smaller black hole kills you earlier. You do not even make it to the point of no return. You are destroyed in the approach, torn apart by forces so extreme your molecular bonds snap like thread. The supermassive black hole at least lets you cross the threshold before it kills you. The stellar mass black hole does not wait. The closest known stellar mass black hole is Gaia BH1, located about 1,560 light-years from Earth. Discovered in 2022, roughly 10 solar masses, in a binary system with a sun-like star. There are an estimated 100 million stellar mass black holes in the Milky Way. Most are invisible, unless actively feeding or in binary systems where their gravitational influence can be measured. They are out there. They are small, and they are worse. Number 5. They turn matter into screaming hot death disks. Black holes do not kill quietly. The matter dying around them creates the brightest, hottest structures in the universe. The black hole itself is dark. The death it causes is blinding. Matter does not drop straight in. It spirals. Conservation of angular momentum forces material into a rotating disk, an accretion disk. As matter spirals inward, it compresses. It heats up. Friction between particles moving at different speeds generates enormous temperatures. The sun's core reaches 15 million Kelvin, hot enough to fuse hydrogen into helium. Accretion disks around black holes reach temperatures exceeding 100 million Kelvin. Some reach billions of degrees, hotter than the cores of the most massive stars, hotter than anything else in the universe except the moments immediately after the Big Bang. At these temperatures, matter does not glow in visible light. It screams in X-rays and gamma rays, high-energy photons that can only be produced by extreme violence. X-ray telescopes like Chandra and new star detect accretion disks across the universe. The signature is unmistakable. Wherever you see X-rays pouring from a compact region, something is dying in a black hole's grip. The black hole emits nothing, perfectly black. But the accretion disk glows so brightly it can outshine entire galaxies. Quasars are supermassive black holes with exceptionally bright accretion disks. A single quasar can emit 10^12 to 10^14 times the sun's luminosity, more light than a trillion stars, from a region smaller than our solar system. Quasars can be detected across billions of light-years. The most distant known quasars are over 13 billion light-years away. We see them as they were when the universe was less than 1 billion years old. Even at that distance, even across that span of time, the light from matter dying around a black hole is bright enough to reach us. Cygnus X1 was the first black hole candidate ever identified. A stellar mass black hole in a binary system, pulling matter from a companion star. The accretion disk glows in X-rays. Temperatures reach tens of millions of degrees. The black hole is invisible. The death spiral around it is not. The darkest objects in the universe create the brightest phenomena. Black holes emit no light. The matter falling into them outshines galaxies. The universe's ultimate erasure machine is surrounded by a halo of screaming, superheated gas that announces its presence across cosmic distances. The black hole does not glow. The death does. Number 4. They may slowly evaporate, but not in a comforting way. Black holes may slowly evaporate. This is not good news. This is the universe dangling hope and then explaining why the timeline makes it irrelevant. Hawking radiation. A quantum effect at the event horizon. Virtual particle pairs pop into existence near the boundary. Normally they annihilate immediately. Near a black hole, one particle falls in while the other escapes. The escaping particle carries away energy. The black hole loses mass. Over absurdly long timescales, this can cause complete evaporation. Stephen Hawking proposed this in 1974. One of the few theoretical mechanisms by which black holes can die. So maybe we can wait them out. Maybe the universe will clean up its own mess. No. Evaporation time is proportional to the cube of the black hole's mass. A stellar mass black hole with 10 solar masses would take approximately 1067 years to evaporate. A 1 followed by 67 zeros. The current age of the universe is 13.8 billion years, about 1.38 times 10 years. The black hole's evaporation time is 1057 times longer than the current age of the universe. For comparison, proton decay, if it happens, is estimated at 1034 years or longer. Already incomprehensibly distant. Black hole evaporation makes proton decay look quick. Supermassive black holes are worse. A billion solar mass black hole would take roughly 100 years to evaporate. That number is so large, it loses meaning. The heat death of the universe, the point where all usable energy is exhausted, will occur long before any supermassive black hole evaporates. The universe will be cold, dark, empty. Those black holes will still be there. Hawking radiation is real. The math works. Black holes are not truly eternal. But the timescales are so extreme that not eternal is functionally identical to eternal for anything experiencing time the way we do. Waiting for a black hole to evaporate is not a strategy. It is a joke the universe plays on anyone who thought there might be an exit. The universe offers you a way out. Then it sets the timer to 1067 years and walks away. So no, we cannot just wait it out. By the time a stellar mass black hole evaporates, every star will have burned out, every planet frozen, and the concept of waiting will have lost all meaning. The black hole will outlast everything except the void itself, and even then, it will take its time leaving. Number 3. They distort space itself. Black holes are not objects sitting in space like planets. They are not things you can fly around. They are regions where space-time is warped so violently that normal intuition breaks. Near one, straight ahead can mean into oblivion. General relativity tells us mass curves space-time. The sun curves it enough to keep Earth in orbit. A neutron star curves it more. A black hole curves it to the breaking point. At the event horizon, space-time curvature becomes so extreme that all paths lead inward. At the singularity, curvature becomes infinite, and the equations fail. This is not metaphor. This is geometry. Light cones the mathematical structures defining which directions you can travel tip toward the black hole. Once you cross the event horizon, every direction you can move, every path you can take, every possible future points toward the center. There is no up. There is no away. All directions are toward. The photon sphere sits just outside the event horizon. Spacetime is curved enough that light itself can orbit the black hole. Photons traveling tangentially at this radius circle indefinitely. Closer than this, even light moving perpendicular to the black hole gets pulled in. The universe has created a region where geometry itself is hostile. Rotating black holes drag spacetime around them. Frame dragging. The black hole's spin twists spacetime like a whirlpool. Objects near a rotating black hole are forced to move in the direction of the spin. Spacetime itself is rotating. You cannot hold still relative to distant stars because the fabric of space is being dragged beneath you. Frame dragging has been measured around Earth using gravity probe B. Around a black hole, the effect is millions of times stronger. Inside the event horizon, the roles of space and time swap. Radial distance becomes time-like. Moving toward the singularity is not a choice. It is as inevitable as moving forward in time. You cannot stop moving toward the center any more than you can stop moving into the future. The singularity is not a place you will reach. It is a moment in your future you cannot avoid. Black holes do not just trap matter. They trap geometry. They warp the structure of space so thoroughly that directions lose meaning, paths collapse inward, and the future itself points toward annihilation. You cannot navigate around this. You cannot plot a course that avoids it. Once you are close enough, space-time itself is the trap. And the universe manufactures these regions naturally, constantly, as standard output of stellar evolution. Number 2. The universe makes them naturally. Black holes are not cosmic accidents. They are not freak events requiring perfect conditions and astronomical luck. The universe makes them naturally, constantly, through multiple pathways, as if it wanted redundancy in its erasure systems. Massive stars collapse into stellar mass black holes. Any star above roughly 20 solar masses ends its life in a supernova. If enough mass remains after the explosion, gravity crushes the core into a black hole. Not a neutron star, a black hole. The Milky Way produces an estimated 1 to 3 stellar mass black holes per century. The galaxy is 13.6 billion years old. Current estimates put the number of stellar mass black holes in our galaxy at around 100 million. Supermassive black holes grow at galaxy centers. Every galaxy with a bulge has one. Not optional equipment. Standard. The mechanism is debated: direct collapse of massive gas clouds in the early universe, or growth from smaller black holes that merged and consumed matter over billions of years. Either way, they are standard galactic architecture. Black hole mergers create larger black holes. When two spiral into each other, they release gravitational waves and merge into a single, more massive black hole. LIGO has detected dozens since 2015. The universe is not running out of black holes. It is consolidating them into bigger ones. Intermediate mass black holes exist in globular clusters, between 100 and 100,000 solar masses. Harder to detect than stellar mass or supermassive cousins, but observations suggest they are out there, quietly accumulating mass. Primordial black holes may have formed in the early universe. Theoretical, but if they exist, they formed from density fluctuations in the first fraction of a second after the Big Bang. The universe may have been manufacturing black holes before the first stars ignited. The production pathways are diverse. The scale ranges from stellar mass to supermassive. The locations span galaxy centers to globular clusters to interstellar space. Black holes are not confined to exotic regions. They are woven into galactic structure. They are byproducts of stellar evolution. They are inevitable outcomes of gravitational collapse. Space did not need a villain. Gravity already applied for the job. The universe did not import destruction from outside. It built the tools in-house, tested them, deployed them across every galaxy. Black holes are not anomalies. They are features. The universe manufactures them with the same efficiency it uses to make stars. The difference is that stars eventually die. Black holes do not. Number 1. The universe manufactures them. Black holes are not cosmic accidents. They are not rare glitches in an otherwise orderly universe. They are what happens when physics follows its own rules to their logical conclusion. The universe does not forbid black holes. It requires them. Any sufficiently massive object will collapse into a black hole. There is no force strong enough to stop it. Electron degeneracy pressure can hold up a white dwarf, but only up to 1.4 solar masses, the Chandrasekhar limit. Beyond that, electrons cannot resist gravity. Neutron degeneracy pressure can hold up a neutron star, but only up to roughly 2 to 3 solar masses, the Tolman-Oppenheimer-Volkoff limit. Beyond that, even neutrons packed to nuclear density cannot stop collapse. Past those limits, nothing resists. No known force, no exotic matter, no quantum pressure. Gravity wins. The object collapses into a singularity, a point where density becomes infinite and general relativity's equations break down completely. Physics does not know what happens at a singularity. It just knows one forms. General relativity predicted black holes in 1915. Observations have confirmed them repeatedly. X-ray binaries where invisible companions pull matter from visible stars. Gravitational waves from black hole mergers detected by LIGO. The Event Horizon Telescope image of M87*S shadow. Black holes are not theoretical curiosities. They are observed, measured, catalogued. They are not bugs in the cosmic code. They are features. The universe generates black holes as naturally as it generates stars. Massive stars collapse into stellar mass black holes. Galaxies grow supermassive black holes at their centers. Black holes merge to create larger ones. The process is automatic. Gravity does not need instructions. It does not need malice. It just needs mass and time. We exist in a universe that manufactures oblivion. Space did not import a villain from outside. Gravity applied for the job, and the universe hired it on the spot. Every galaxy carries an erasure machine at its core. Every massive star is a future black hole waiting to collapse. The universe builds its own executioners, winds them up, sets them loose. Black holes are not anomalies. They are what the universe does when left to its own devices. So the next time you look up at the night sky and feel wonder, remember this. Those stars are not just light sources. Some are countdown timers. The universe is not indifferent to your existence. It is actively hostile. It has designed, tested, and mass-produced the ultimate predator. It did not bother asking for permission. That is what black holes prove. Space does not want to erase us because it hates us. It wants to erase us because that is what it was built to do. If this filled you with existential dread, subscribe. If you are now questioning your place in a universe that manufactures doom, hit like. And comment where you are watching from, preferably somewhere far from the nearest black hole.